All right, review number 6, determine the slope and intercept, what it means within the context for this graph. So we talked about this one as well. We even did this problem in class. So the slope here is the rise and the run. We talked about pay attention to the scales, because if the scales are different, you cannot count the boxes, okay? You must look at the actual values that you are rising and running, and just find 2 nice points where you can get exact coordinates. So what I mean by that is we have a nice y-intercept point here. Let me do this in a different color. So our y-intercept is at 0.8. So at 0 hours, we have a height of 8 inches on this candle. That just tells me the candle was 8 inches when it started. And then find another nice point. Okay, so that looks like 1.5 hours and 6. I could look for more nice points. There's 3 and 4. I'll just put these down as we go. So these are the coordinates I'm seeing. This looks like 4.5 and 2. Then way over here, we have 6 hours and the height is 0. So pick any 2 points and calculate the rise and the run, the y change and the x change. Okay. For me, if I can see an x-intercept and a y-intercept on the same graph and it's linear, I choose the x-intercept and y-intercept to do this. Okay. So I'm going to say that we start at 0.8 and then we're going down to 6.0. So how much do the y's decrease? I go from 8 down to 0. So my y change, if I was to actually list these this way, about 0.8 goes to 6.0. My y went from 8 to 0. That's down 8. -8 is the y change. My x's went from 0 to 6. So the x change went up +6. So we get a slope of -8 over 6. You can simplify that a little bit and say -4/3. And there's 2 ways to break this down. That means every 1 hour, each hour, the height of the candle, the y value. So the reason I said each hour is because that's the x. You always say that the slope tells you for each x, in this case, for each hour of time, the y, the height in this case, because it's a negative slope, that means the height or the y is decreasing. So it decreases by 4/3 of an inch. And when I use the word decreases, that's taking the place of the negative sign in the slope. So it decreases by 4/3. I wouldn't say decreases by -4/3. I would just say decreases 4/3. The word decreases indicates that it's a negative slope. Okay, slope is negative. If you had a positive slope, you would just replace the word decreases with increases. So that's one way you could describe it. You can also say that the bottom number of a fraction slope is like however many hours it's increasing. So I could say each 3 hours or every 3 hours, then the height decreases by just the top number of that slope. So every 3 hours, it decreases 4 inches in height. Okay. And you can actually see that here. We go over 3 hours from the time it started. The height went from 8 down to 4. That's -4 inches in 3 hours. Okay. And that's why this simplifies to just, we say -4/3 of an inch per hour. But you can think of it as every 3 hours, it goes down 4 inches, or -4/3, which is like -1.33 inches per hour. What is the domain of the function? Domain, once again, that's the x values. So we would say all the times, all the x's from 0 to 6, because if we go longer than 6 hours, the candle has stopped burning. So this function doesn't really apply anymore. And we can't go into negative time because before the candle was lit, it's not like it should have been taller than it was now. So 0 to 6 hours. How long would a candle with an initial height of 24 last if it burned at the same rate? So what if it started at 24 and burned at the same rate? Well, let's go to Desmos and help us out with this one. That means our function would change and we would have f of x. And you can say just y here if you wanted to, but f of x, I want to do it as a function. The initial height is 24 minus 4/3 x. Okay, so let's see what happens. What's the change in the domain here? Let me zoom back in on my normal graph. If you ever want to zoom back to the start, hit the home button, and then you can zoom out. That always works. So now what's the difference? Well, If it was initial height of 24, now it looks like it can burn instead of just to 6 hours, it can burn up to 18 hours. Okay, so how long would a candle with initial height of 24 last? It would last 18 hours. Because looking at that new graph, if it starts at 24, then it burns out at 18. Okay, and that kind of makes sense too, because look, if it originally started at 8 and that goes up to 24, that means that's 3 times as tall. And because it's linear, it's going to take 3 times as long. It used to take 6 hours, now it takes 18. And 6 times 3 is 18. Compare the slope of the function for the original candle above to the slope of the linear function for a second candle, whose x-intercept is 4 and y-intercept is 12. So let's talk about that. X-intercept of 4, 0. Y-intercept of 0, 12. Okay. So let's do our rise and run here. Y change over X change. Well, first off, let's just talk about this. The y-intercept is 12 means this candle was 12 inches tall when it started. And the x-intercept of 4 means it burns out in 4 hours. So it's taller than this one. And I'm going to actually draw it on this graph. Then it burns out here. Look at the slope. It's steeper, right? That's a steeper slope, which means is it burning slower or faster? Hopefully you can say, well, clearly that's burning faster because it takes less time and it was taller to start with. So it's a lot faster probably. So it's going down 12 inches, burning all the way out in 4 hours. That means it's burning at a rate of -3. It's burning 3 inches for every 1 hour, 3 inches per hour. That's a lot more than the -1.333, which is what -4/3 would be. So what can we conclude about the second candle? It is taller, but burning faster than the first. The second one is taller, but it is burning faster than the first. And finally, number 5, I'm assuming this is talking about the original candle again. So let's just go back there. After how many hours was the height of the candle 6 inches tall? So 6 inches tall would be the Y value. And if we look at the graph, that lined right up with 1.5 hours. So that's just, can we look at a graph and make sense of the context to identify specific values on that graph? And that's it for review number 6. If you have any questions on that, feel free to email me.